So our today's topic is we call it polar coordinates. Before we are familiar with these xy coordinates, which we also call them the Cartesian coordinates. Suppose that here we have a point xy, mean xy are the coordinates of this point. So what does the meaning of x and y? For example, if we draw a perpendicular line from this point to the x-axis, so from this origin to the foot of this perpendicular, this distance, it is called x, and from this vertical distance, it is called y. So these are called x and y coordinates, or the Cartesian coordinates of the point P. But now, what are the polar coordinates? The polar coordinates are denoted by r and theta. So think about this thing. For example, we have the same xy plane and the point P. We are going to join this point P with the origin. And the distance of this point from the from the origin, it is denoted by the letter this r. Okay, r is the radius, or you can say the radius of the distance of this point from the origin, and the angle, this angle with the positive x-axis, it is denoted by theta. So what are the polar coordinates? The polar coordinates of the point are r and theta. R is the distance, theta is the angle which this line OP, or the vector OP, makes with the positive x-axis. The next thing you need to remember, how do we find them? For example, from the Pythagoras theorem, if you remember, this is that's our right angle triangle. Here we have A, this is B, and this is C. From the Pythagoras theorem, it says that the C square is equal to A square plus B square. So if we join this point P with the origin, and this is denoted by R, so from this right angle triangle we are going to get the following condition, which you can denote this thing with the following: r square is equal to x square plus y square. Okay, and the second equation we are going to get, for example, this is theta, and from our previous knowledge about the trigonometry, we know that tan theta is equal to, you can write this thing in the following way: opposite our adjacent. Opposite our adjacent mean amud ala qaida. So from here, our second equation is going to be tan theta equals y over x. So these are, you can say, the relationships between r and theta. What is the use of these two equations? For example, if we are given the coordinates of a point in the xy, okay, so by using these conditions, you can use above equations to find r and theta. Okay, you can use above equations to find the value of r and the value of theta. Okay, again, there are some other relationships. We know that tan theta equals to opposite over adjacent. This is called the opposite. This A you can call this adjacent, yani qaida, and C is called the hypotenuse. C is called the hypotenuse. So from here we get these equations. What is the sine theta? We know from our trigonometry that sine theta equals opposite over hypotenuse, and we have another equation cosine theta which is equal to adjacent our hypotenuse, yani qaida ala witr. So from this triangle, this first one triangle, okay, so here we have x and this is y. So from these we are going to get two different equations for the cosine theta and also for the sine theta. So the cosine theta, it will be equal to adjacent over hypotenuse, that will give us x by r. And what will be the sine theta? Sine theta, it's equal to y over r. And if you rewrite them in the following way, for example, you can bring this r to the left hand side, it becomes r cosine of theta, and y equals to r sine of theta, r cosine theta, and y equals to r sine theta. And what is the use of these two? For example, if we are given the polar coordinates of the point, for example, we are given r theta, so by using these two conditions you can use these above equations. You can use these above equations to find the values of x and y, or you can say the xy coordinates of the above point. So you can use these two relations. So this type of the questions will be given to you in the questions. Okay, there is another thing you need to remember, how to sketch them. We will do this thing, but first of all we do some example related to this thing. We are going to use some relation. Okay, let's do this question. Okay, so this is our example. So this example says that we are given a point in the polar coordinates. So convert the following point to pi by 3. So this is in polar coordinates. This point, it is in polar coordinates. So what you need to do, you need to find x and y. You need to find x and y. So what is the value of r from here? This is r, and theta equals to this pi by 3. Theta equals to pi by 3, and you can use these above relations to find the values of x and y. For example, x equals to r cosine of theta, and when we substitute these values we get 2 multiplied with cosine pi by 3. Pi by 3, it is 60 degree, and we know that cosine 60, it is equal to 1 by 2. Cosine 60 is 1 by 2 or half. So this 2 cancels with this one and the answer is 1. So it means that the value of x equals to 1. And similarly we can use the second equation to find the value of y, which equals 2 multiplied with sine pi by 3, and we know that sine pi by 3 it is equal to under the root 3 by 2. Again this 2 cancels with this one and we get square root of 3. So it means that what is the value of x and y? X equals to 1 and y equals to square root of 3. So we can convert this point into xy. Okay, now let us do a second example. Let's do a second example. So in this example we are given the Cartesian coordinates of a point xy equals to 1 minus 1, and what is the question? The question is the following, that you need to find r theta. You need to find r and theta. R and theta mean the radius and theta. So what is the value? How can we find r square? We know that r square is equal to x square plus y square, and when we substitute these values, 1 square plus minus 1 square, it will give us 1 plus 1, which is equal to 2. And how can we find the tan theta? You can find tan theta equals to y by x, which is equal to which will give us minus 1 by 1, and it's equal to minus 1. And if you do this thing, theta equals to tan inverse of minus 1, it will give you minus pi by 4. It will give you minus pi by 4, or you can also write this thing pi minus pi by 4. Here x is positive and y is negative. X is positive, y is negative. So it means that this point is in the fourth quadrant. So that will give you the following. So here we are going to write 2 pi minus pi by 4, which is equal to which becomes 7 pi by 4. Okay. In order to do this thing, you need to consider this thing. This point lies here in the fourth quadrant because x is 1, y is minus 1. So there are two different ways you can measure the angle. One of them is the following. You can go anti-clockwise. Here theta equals to minus pi by 4. And the second way to do this thing is to go clockwise. Clockwise mean in this way, and that will give you theta equals to 7 pi by 4. So that's how you can convert Cartesian coordinates into the polar coordinates, and also you can convert polar coordinates into the Cartesian coordinates.